Welcome to the demonstration of MiSAR, the Microservice Architecture Recovery Toolset. All the installation manuals and user guidance can be found on MiSAR's GitHub repository. The MiSAR toolset implements the MiSAR approach. The aim of MiSAR is to allow software engineers to semi-automatically recover architectural models of implemented microservice systems. To do that, it follows the model-driven architecture framework. As a user of MiSAR, the first step is to use the MiSAR parser, which analyzes the microservice-based system that we want to recover its architectural model, and it will generate a platform-specific model. The platform-specific model is an abstract representation using technologies of the microservice system. The second step, we can use the model transformation engine, which will generate the platform-independent model, which represents the recovered architectural model of the microservice system. Now, in step 3, the graphical model generation component can be used if the user would like to obtain UML graphical diagrams of the architectural model. In the following, we're going to demo the MiSAR approach and toolset by recovering the as-implemented architecture of a microservice-based system called MicroCompany. MicroCompany is an open-source project which is implemented in Java Spring Boot Cloud, and it utilizes both synchronous and asynchronous communication among microservices. The first step to use MiSAR is to use the MiSAR parser. Here you can see the user interface of the parser, which allows to indicate and locate which project and files need to be parsed. In this case, we're going to parse the MicroCompany project. So we are just going to create the name of a MicroCompany project name. Now, we will select the multi-module project build, or we have already selected the PSM eco meta model, Docker compose, and the POM of the project. We will now select the module projects build directories. We will also select the module project POM build files. We can now press create PSM model. As you can notice, in a few seconds, the parser will create the PSM of the MicroCompany. In this case here, we can see the time that it took for the parser to create the PSM. The second step is to use the model transformation engine, which will automatically generate the as-implemented architectural model in XML or eco format from the platform-specific model of MicroCompany. Here you can see that we have already imported the platform-specific model generated by the parser. Now, we will go and execute the model transformation engine. To do that, we will have to first indicate in the source the location of the platform-specific model. Then in the out target, we will also locate where we would like the architectural model to be generated and give a name to the file. Now we will run and we will wait a couple of seconds till it will appear in the target. As you can see, the PIM recovered architectural model has been generated. If we would like to explore it, as you can see here, we have the recovered architectural model, MicroCompany, which has 11 microservices. 5 of them are functional and 6 of them are infrastructure microservices. We can also have a deeper view of any microservice. In this case, we will have a view of the query side blog. As we can see the container, its infrastructure pattern components, its client components. We can also see its service interface and its set of endpoints and queue listener, which represents the synchronous and asynchronous communication of the microservice and its service dependencies. The third MiSAR tool component is optional and is the graphical model generator. The user uses it if they would like to generate graphical UML diagrams of the recovered architectural model. The first thing they have to do is locate the PIM file, which contains the recovered architectural model. As you can see here, we have the architectural level and the microservice level. At the architectural level, you can create an Excel sheet which provides the number of all architectural element types of the architectural model. As you can see in the Excel sheet, there are 5 functional microservices, 6 infrastructure microservices, 11 containers, and for example, 3 queue listeners. At the architecture dependency view, we can create an image with the UML diagram with all the functional and infrastructure microservices and their service dependencies. Blue components indicate functional microservices and purple components indicate infrastructure microservices. At the microservice level, you can choose a specific microservice from the top-down menu. We are going to choose circuit breaker. You can generate an Excel sheet with the number of elements related to that circuit breaker, but we will now generate and create the dependency view. In the dependency view of circuit breaker, we can see circuit breaker and the service dependencies it has with other microservices of the architecture. We have come to the end of MiSAR's demo. Hope you enjoyed it.